Hey there, everybody. So I'm going to finish going over the notes from the plate tectonic or plate boundary notes Google slideshow. So we went over 1 through 6, and then we did the lab mapping the plate boundaries. So we're going to start with slide 7 today, and that is where I will present it from. Okay. So plate boundaries are where pieces of the lithosphere meet and move. And since they can meet there and move along those boundaries, they can create cracks in the crust. And this is what we call fault. So what is a fault? It's a giant crack in the Earth's crust where earthquakes occur. So where you can have movement, where two giant slabs of rock are meeting, that's what we call fault. And since you can have movement, that's where earthquakes get generated. So you have a little chart here with your major boundaries: divergent, convergent, and transform. You're always going to have a plate tectonic map to use, so you should always have that out because it gives you a lot of answers. So the divergent boundary is going to have the arrows moving apart, which means plates separate. So if it's separating, then you're going to have a mid-ocean ridge or a rift valley. So if it's the continent moving away from continent, that's the rift valley. If it's moved away far enough that seawater has flooded it, then we simply call it a mid-ocean ridge. This is where the seafloor spreading is occurring, which creates new seafloor at the mid-ocean ridge. And it forms a type of fault called a normal fault. It's only called a normal fault because it was the first one identified and studied. Okay? It's not like one is abnormal and one is normal. We'll take a look at them later in the unit, what they look like and how to identify a normal fault. So there's a divergent boundary, moving away. So diverge means to move away. Therefore, converge is the opposite, to come together. So convergent boundary, plates collide. And if two things collide, the middle can go up. So you could get a mountain range, volcanic islands, or volcanic mountains and trenches. So this boundary is probably the most diverse in terms of the landforms that it creates. You have what's called a subduction zone. So where the plates collide, the denser ocean plate will dive. Dive means subduct under the less dense plate. And it forms the opposite of a normal fault. So since this was the second one identified, we call it a reverse fault, just because it's the reverse of normal. All right. And here's a picture of a convergent boundary. The last major plate boundary is called transform. So plates aren't colliding and they're not separating. Instead, they're sliding past one another. So plates slide past one another. Since they're sliding past, since they're going sideways and not colliding. See, if it collides, and something can go down, or things can buckle upwards. Or if they separate, it leaves a hole for water to flood. But if they're just sliding past, there's no vertical motion. It's just side to side motion. So all you have is shaking. So in a transform boundary, you only have faults and earthquakes. We call these types of faults strike slip faults. Sometimes they're called lateral faults or transform faults. The most famous fault in America runs through California. It's called the San Andreas Fault. There's a picture of just side-to-side motion. Okay, so let's play this little clip.
In some regions, plates spread apart, creating new crust. At other locations, plates move toward one another in a slow motion collision that takes place over millions of years. Deep ocean trenches outline many of these zones as one plate sinks beneath another. And in a few places on Earth, including California, plates grind against each other, slowly moving side by side in opposite directions. It takes our most sensitive instruments to detect these motions, but over time, they have transformed the surface of Earth.
Okay. All right. So there's two types of divergent boundaries. So you can have what's called rifting. That's when continents separate from continents. And that's the image on the left. Okay, so this image right here. Let me bring up a laser instead. Okay. This image right here, okay, is a rift valley. So you have a plate going, one side going to the left here, and another so going up, and this side going to the right, causing the middle to drop and making a valley. I'm going to play this clip.
When a plate carrying continental crust breaks apart, the resulting divergent boundary is called a continental rift. Rifting is usually preceded by the formation of a volcanic bulge, as the horizontal stretching and vertical thinning of the lithosphere causes the asthenosphere beneath to rise. As the lithospheric mantle stretches, the cool and brittle crust above fractures and faults develop. This creates large fault blocks of crust that slide down into the widening rift. These mountain...
Oh, great. So the reason I wanted to pause it is to show you those cracks right there. Those are your normal faults, all right, that I mentioned. Let's go fast forward to where we were at.
When a plate carrying... As the lithospheric mantle stretches, the cool and brittle crust above fractures and faults develop. This creates large fault blocks of crust that slide down into the widening rift.
Those are your normal faults.
These mountain-sized blocks, called ranges, erode, and the produced sediments fill the valleys, called basins, in between. As the stretched lithosphere thins, asthenosphere rises and melts. Some of the magma erupts as lava, creating volcanoes along and near the center of the rift.
Okay. So rifting is when continental plates are moving apart, creating a rift valley. The world's most famous rift valley is called the East African Rift Valley, and that's also in the reference table in the plate boundary chart. You should have seen it. It's more of a complex boundary, but it's mainly divergent. In those charts, the ones that say complex, it means the motion could change. Sometimes it's moving away, sometimes it's transformed. So we're not exactly sure. So we just classify it as a complex boundary. Okay, so oceanic divergence is how you get the mid-ocean ridge. You don't need to hear that. I played this clip before, just without the summary. So as hot mantle rock rises, begins to melt, and forms new rock, and then it moves to the side. And it takes the rock with it. It just takes the rock for a ride. So the further the rocks are from the ridge, the older the rocks get. And we spent a lot of time going over this with seafloor spreading. So oceanic divergence is the same thing as seafloor spreading. Okay, so it causes seafloor spreading. So it creates new crust and causes seafloor spreading. And it forms a mid-ocean ridge. All right, so now we're going to go into convergent boundaries. These are the most diverse of the groups of the three major kinds, because there could be three different types of convergent boundaries. And that's because there's two types of crust. So that's weird, right? You have two types of crust, but you have three types of boundaries. That's because you can have ocean crust colliding with continent. You can have ocean crust colliding with ocean. Or you can have continent colliding with continent. And that's what we see here in this picture. And that's how you get the world's largest mountains. Right? And that's what happened in the Himalayas. So you have continental crust here on the left colliding with continental crust on the right. It's like two huge Mack trucks hitting head on. In the middle is your crumple zone or your mountain range. What happens is it starts, see here, it starts to subduct and then the subduction stops. It's really a doubling of the Earth's crust. That's what happened in the Himalayas. And that's why they're so high. The Earth's crust kind of almost doubled. We call it a thrust fault. So you have one crust and then the other crust kind of thrusts itself on top of the other. Get it? It gets thrown or thrusted over. We call this thrust fault. And this is going to show you a little animation of it. So there was subduction initially, and then here comes India. India collided with the rest of Asia. The subduction stopped, and it just really lifted that entire region. All right, forming the Himalayan mountains and what's called the Tibetan Plateau. So in a continental convergence, two continents collide. There's no subduction. So since there's no subduction, there's no trench, and you can't have volcanoes without subduction because the plate can't melt because it's not diving back into the mantle. So that's one good thing, I guess. The Himalayas have no volcanoes. They do have major earthquakes, but no volcanoes. You get what's called a folded mountain range. The rocks are literally under such pressure that the rocks fold. All right, the other kind of convergent boundary is if the ocean collides with the continent. And this is what's happening off the west coast of South America, forming the Andes. So the picture on the left here is showing the ocean crust. Okay, it's showing the ocean crust. Here's the ocean crust hitting the continental crust, and then the ocean crust dives down. And the reason it dives down is ocean rocks are denser than continental rocks. And the point where it dives down, you get this trench. And then here it begins to melt and you get volcanic mountains. Okay, so we'll play this video now. So this is showing the ocean crust colliding with the continent. It subducts. Where it subducts, you get a trench. And then it begins to melt and you get volcanic mountains. So where in the world do you have this going on? In the Andes Mountains in South America. In a beautiful region in North America called the Cascades. That's in Washington State and Oregon. And Vancouver Island in British Columbia. They're all volcanoes there. So the most famous American eruption is caused by this boundary. The most famous one is called Mount St. Helens. Happened in 1980, way before you guys were born. I was only 2 years old. But it was such a big eruption that ash from that eruption made it all the way to New York. So the volcano was in Washington State, and the wind blew the ash to New York. That's how big of an eruption it was. So in the oceanic continental convergence, the ocean plate collides with the continent. The ocean plate will subduct. You get a deep sea trench. And you get a volcanic mountain range. Why does the ocean plate always subduct? Because it's denser. Ocean crust is more dense than continental crust. All right, the final convergent boundary is if ocean collides with ocean. And since ocean's colliding with ocean, you can only be surrounded by ocean. So you get islands. The denser ocean crust is still going to subduct. So whichever one is subducting is your denser crust. So you still have subduction, you still have a trench, and you still have volcanoes, but this time they're volcanic islands. And you see this all along the Asian Pacific coast. Japan, Philippines, Indonesia, New Zealand. These are all volcanic island arcs. Right? Not Hawaii. We're going to learn about Hawaii last. So here you have one plate hitting another. The denser ocean plate will subduct. You have a trench at the point of subduction, and the plate will begin to melt and come back in the form of a volcanic island. And these islands grow all the way from the seafloor. Okay? You have a copy of these notes, and all these videos are embedded, so you could play them again. All right? So in oceanic convergence, ocean plates collide with another ocean plate. One of the ocean plates subduct. The one that's going to subduct is the denser one. You get a trench on the subducting plate, and you get volcanic islands on the overriding plate. Japan, Philippines, etc. Which plate will always subduct? It's a common question. The denser plate. All right. All right, so what this is showing you is all three together. Well, let me go back. So here you have ocean. This is the first one. Ocean. Not the first one in the notes I went in, but I'm just telling you. This is the first dot. The top diagram here is showing ocean convergence. This second one is showing ocean-continental convergence. And this last one is showing continental convergence. So it's trying to show you all three in one page. All right, the last major plate boundary is called transform. So a transform plate boundary, plates are moving laterally. That means sideways. So the plates are just sliding past one another. You only have earthquakes in the San Andreas Fault. So you don't really have major landforms. It's just a sideways, it's just shaking. All right, I'm trying to play this video. So here you have the fault, that's the crack, and then you have your earthquake and it shifts. So it just goes to the left or right. There's no up or down. But it still produces a lot of shaking because the earthquakes are pretty shallow, which means they're close to the surface. Okay. Here's an aerial view of the San Andreas Fault running through the desert of California. But it goes all the way up to the San Francisco Bay Area. So it goes all the way from like Southern California through Central or Northern California. So here's a wall that was broken by the fault. The San Andreas Fault always shifts things to the right, laterally compared to the other side. So we call it a right lateral strike slip fault. See how imagine that this was all together. See this side right here got moved to the right. And then you see this fence. So this side got moved to the right. So if you live in California and you're on one side of the fault and someone's on the other side, the person will always move to the right after one of their earthquakes. That's how they always move there. Okay, the major earthquake in Haiti a few years ago is also a transform fault. I believe that one is a left lateral fault. So that way everything will move to the left. And here's just a great little diagram showing you all the boundaries in one image. Okay, so right here you have ocean colliding with ocean. Here you have divergent. Here you have ocean colliding with continent. And here you have rifting. So this is just missing continental convergence. And this is we're going to learn with hotspots last. So this would be like where Hawaii is. Okay, we're going to end with one last video, and that'll do it for the lesson. It's a long one. So I'm actually not going to play it all. Actually, I'm going to pause it. You can play it yourself. All right, it kind of sums up everything we've been doing up to this point. So after this, we're going to go over hotspots, and then we're going to actually go over specific seismic waves and how we can use them to tell us where earthquakes occurred. All right, and we'll also learn about the different types of faults. It's a big unit, all right, and we're slowly getting through it. If you have any questions, always feel free to email me or ask me at our Google Meet sessions. All right, have a great day.